I'm spinning off something and that comes back. But Reactive is much more than that. It takes from you the burden of synchronization, the burden of concurrency control to feed back things together and make sure that if you have a fast producing source and a slow consumer, that your consumer isn't overrun. That's what we call pull, push, back pressure. It comes with the idea of flow control, which basically takes the for loops, the while loops from you away. And by doing so, you just specify really the recipe, the stream, the flow that you want to achieve. And then on top of that, the reactive framework is going to do its work. So let me see whether we can get the slides up and working. Because now I think that would be a good idea to have the slides, because then I have to talk less. No, just kidding. Here we go. Perfect. Cool. Thanks. So, if one wants to use reactive programming all the way long within your application stack, then you might encounter some sort of barriers. And this is because reactive programming is still new. Although these things started years ago, like in 2013, when Netflix, Pivotal, Twitter, and a lot of other companies sat down and established this idea of the reactive streams specification, which is an interoperability standard. And from there on, parties started adopting the reactive idea. And we have already integrations with HTTP clients, with messaging systems. But still, the idea of propagating back pressure is limited to in-process computing. If you want to go outside of your process, say talk to a different service or to an integration, then this is the boundary where all these back pressure information is basically lost, because we cannot communicate back pressure over the wire. There is, however, a project in the working which is called RSocket. And RSocket tries to communicate the back pressure information, the flow information, across the wire. This is a topic that is currently being worked on. And if you have the time tomorrow, Oleg Dukuka is going to give a talk about RSocket specifically. If we talk about persistence and data access, then we will see a couple of NoSQL stores which are supporting reactive data access patterns already. And this is MongoDB, Cassandra, Couchbase, Redis, these kind of stores. However, the reality shows us that almost 80%, if not even more, of the data, of today's data, is stored within relational databases, or SQL databases, how Marcus would put it. And so we need to do something about that, and that's the thing that which brings us to reactive relational database connectivity, or how we abbreviate it, R2DBC. R2DBC is an API designed from the ground up for reactive programming, embracing reactive properties and reactive types. What does this mean? Well, every interaction or every method that would start a conversation with a database is fully non-blocking. We no longer have the synchronization model that you need to wait until the method comes back, but rather you get a publisher in your hand. The publisher is that thing that allows you to start and initiate that conversation on a non-blocking level. All the communication, all the design is down to the database fully non-blocking. We are embracing wire protocol features that are provided by databases. So there are things like cursors, which you can ideally use to leave the not consumed part on the server side and read just the portion of the data that you are interested in. That's like one of the ideas. Another idea is to shrink the driver SPI to a bare minimum, to learn from what we have today from Java's database access, and to shrink it and to make it a single-purpose SPI. And that single-purpose SPI is not intended for humane usage per se, but it's rather intended to enable client developers to build on top of that SPI and build the client that you deserve, and that solves your use case in particular. Great question. So what does SPI mean? SPI stands for Service Provider Interface. So that's something which sits below a component and that provides some certain level of functionality to something which builds on top. So like if you have JDBC and you have Juke or you have JPA, then JDBC is the SPI and JPA is your API. Make sense? Cool. So that's a great transition to JDBC, and don't get me wrong, JDBC is great, is a great piece of software, but after a long day, I would like to sit down and knock out myself with writing some good JDBC code. Said nobody ever. So thing is, JDBC is an awesome piece of software. It's a major piece of software. It has, I think, more than 20 years history already. And it's so major, it's broadly adopted, but it suffers from at least one aspect, which is a duality. And the duality is that it should serve, JDBC should serve as API for users, application developers, and as an SPI for client developers. So like a JPA, like a Juke, or like a JDBI is building on top of that. And this led to the fact that nobody is really liking it. So application developers don't like it to use, and client developers don't like it to implement, because it has this huge duality, and in the end, it does not really fit into that what we're trying to achieve. One thing that makes it hard for driver developers is the duplication of efforts. So every single parameter in every single driver has to be bound by a question mark, right? And every driver developer has to build an abstraction on top of their native driver parameter placeholders and emulate this question mark thing. Another thing is JDBC URLs. There is no consistency across JDBC URLs. And these are the learnings that we are taking into account with R2DBC and make it an API that fits into the current generation, that is functional, that is non-blocking, and that is reactive. And in fact, R2DBC consists of 5 interfaces that we care about. There are a couple of more types like enums, but these aren't really the things which are standing in our focus. We start with a connection factory, and the connection factory itself is, like the name says, a factory for connections. We can obtain a connection from there on. And what a connection factory actually is, whether it creates the connection or whether it reuses pooled connections, that's up to the implementation itself. Once we get the connection, we provide methods that abstract the database specifics away, like how to begin a transaction, how to commit a transaction, how to create a statement, how to set the isolation level. And what we also found is that databases have their very own specific and preferred way how they want to deal with a statement itself. In JDBC, we have statement, prepared statement, and callable statement. Who thinks that this is enough? Nobody. Who wants more? Nobody. So the thing is, databases do optimize for the types of statements they do. Like SQL Server, they have direct execution mode, they have a prepared execution mode, but you would use only the prepared execution mode if you want to go for cursors or for parameter bindings. So this shouldn't be really a concern to the user, but rather to the driver to do the best and right thing for you. So that's the idea behind. And if we would create now a statement, then we can add parameter bindings to that. we can indicate that we are interested in returning generated values and eventually execute that. And once we execute the statement, we get one or more results. And a result currently allows for consumption of affected rows. So if you issue an update or an insert statement, then you would take the number of affected rows. Or if you issue an insert statement and want to retrieve the generated keys, then you would consume that through the mapping function. And also results from a select would be consumed through that map function. So who of you is using how is it called? Stored procedures, hard word. So, okay, we assumed initially nobody is using stored procedures because that's an ancient technology. And then people came to us and said, yeah, what about callable statements? We want to use stored procedures because, you know, there's a business logic in there and we need it. And then we started to consider, okay, maybe that's a good idea to add support for that as well. And I think that's something we will see in a future version of the SPI itself. Cool. So the last two methods that I want to talk about are on the row itself. And a row represents one single row within your result set, and you can retrieve from that row either a column value in its native type, so the driver decides over that what the best type is, or you specify the desired type, like to cast a value into string or some specific number type. If you would use now the code that we have seen there, then we will end up with a pretty nice flow. We create a connection. We call the flatMapMany method, which is part of the project Reactor project, to start an asynchronous nested flow. We create a statement, select value from test, execute it, and then we start consuming the data in there. This is simple, cool. Let's take a look on how we would do basically the same with using parameter bindings. And then we see we create a statement in the same way. We declare parameter bind markers. We bind values to them. We are able to specify multiple bindings. So this means if I specify multiple sets of bindings, then I basically issue the query multiple times with different parameters. And the database driver itself can then decide whether to use or reuse prepared statements or what the best underlying strategy for this execution would be. You see also something which might be a bit unusual. And these are the two parameter bind markers, which are $1, $2 here. And this syntax is Postgres native syntax. And as earlier mentioned, we do not intend to build another abstraction on top of bind markers or on top of something which is just intended for user convenience, but rather we want to embrace what the database properties are and propagate these ideas. For some use cases, portability is key. For other use cases, portability isn't really necessary. And that's a thing that a driver shouldn't really be concerned with, but rather that's a thing that a client should be concerned or an application should be concerned. If that's key to your application, then choose a driver which brings you this feature. If you don't need that feature, then you get rid of a lot of overhead. Now, when we put transactions into that picture, then the code starts to blurry. We have a begin transaction, we have a commit transaction, we have a rollback, and all this is already possible, but that's starting not to be fun again. So the API is verbose, and that's on purpose. That's not to annoy you, but rather to just expose the abstractions over the wire protocol features and to enable client developers to leverage these features and then to deliver a better user experience to yourself. So we all know this finally try catch pattern from JDBC, where we try to do something. If the if that thing what we try to do fails, then we go into the catch, and then we have to roll back and then catch again the SQL exception. And that's basically what you have seen here. So with the intention of providing a basis for humane APIs, we strive to encourage client developers of existing clients and also of new clients to build on top of that API to provide some standard experience which comes out of the box. So inspired by JDBI itself, which is a Java client on top of JDBC, we thought, okay, let's try out something, and we call that RTDBC client. That's a sample implementation of a client inspired along the lines of JDBI. And what we see here is that we have abstracted things away, like the connection handling. We no longer have to obtain the connection and release it ourselves, but rather that's something that the client would do. And with handle method, we get a handle to the current connection. We express, okay, let's start a query, a select query, and then we can start consuming the rows. And this is much more nicer and a much more convenient way to use that API for application use. Another example would be like, let's create an update. And the update has parameter bindings. It can have multiple of these, and we can just execute that. And in a typical use case, we just would await completion or propagation of an error. But in the most cases, we are not interested maybe in the update count or any result that is popping out of the update. Let's talk about transactions. So the only thing that changed is from in handle to in transaction. And all this transactional orchestration, which is bound to my execution flow, is then handled by the client itself and tries to do the most sensible thing for you. You still can affect these kind of things, but the general idea is that you want to have simple, readable code. You don't want to clutter out your entire application with transaction management and all these things that make it quite hard to figure out what the heck is really happening in that end. So we have seen now some examples for the RTDBC client. And if we go then the next step and take a look what will happen in the Spring space, then we will see that there is already some work in progress. With RTDBC, we also were asked, okay, well, for Spring Data JPA or Spring JDBC, we want to have repositories. We want to have something which is a JDBC template, but just for asynchronous database access. And on top of RTDBC, we are able to deliver this experience. We created the Spring Data RTDBC project, and we were inspired by what happened within Spring Web Flux, the functional web API. And as pendant to the web client, we came up with a database client that gives you this natural, fluent experience to declare what you intend to do, to have a fluent way to obtain your data, to declare what should happen. And this is how the code would look like. You spin up a database client from a RTDBC connection factory. You declare that you want to execute some SQL, bind parameters to it, say which type this should be mapped onto, and then you fetch it, either the first row, all rows, something in between. We can take this any further, because if you are already used to Spring Data repositories, then let's leverage this idea. Let's declare reactive relational database repositories on top of reactive CRUD repository. We can use annotated methods to specify the query, and we can leverage Spring specifics. So Spring has this idea of the named JDBC template. And this is a quite handy thing, because the named parameter template translates a couple of things for you into the question mark syntax today already. So if you want to do a query and say, select everything where last name in, And then if you would like would write a JDBC query, then you would have to specify for each and every parameter that it is contained in your collection a bind marker. And that's something that Spring can abstract for you away. And in fact, with this knowledge which database we are talking about, we can abstract even more away. Things like bind markers. You do not need to care within your application code whether that's Postgres syntax with the $1 and so on, or whether that's MySQL syntax with question mark, or SQL Server syntax with add and then name parameter. That's all taken care of by Spring for you. And you just express your query, invoke it, done. Another thing that we standardized is how we deal with connection URLs. So in the JDBC world, every driver has to implement its own JDBC URL parsing. They specify, each and every driver specify its format, and every driver is different in terms of the format. One uses question marks and the URL syntax, how we used it from HTTP URLs. The other use semicolon, and then database name is equals to. And so every time you want to access or specify something from the URL, you have always to look up within the documentation. And it's something we do not really enjoy, but we rather want to pull it into a single central place where you as a driver developer or everybody who develops a driver does not have to care about how the URL is structured, how the URL is parsed, but rather the specification implementation, which is a very tiny part within the SPI itself, takes your URL, creates an intermediate representation of the parameters which are configured in that, and you basically, as a driver, get a configuration object in your hand, and then you can evaluate what's inside of the configuration object. And this makes it for users even more convenient, because you know every R2DBC URL starts with R2DBC. Then comes the driver identifier, and then basically you continue as if it is a true URL. This also gives us a lot of additional flexibility. See, URL-based configuration is very convenient for applications or DevOps people. They want to specify the database endpoint, they want to specify the database itself. But one thing which is commonly omitted from these URLs is credentials and authentications, because these are typically not the things you want to commit to Git or SVN, or you don't want to put it in any property file at all, but rather you want to supply these information in externally. And with JDBC, that's always sort of a hassle, because sometimes you have it this way, sometimes you have it another way, and configuration frameworks can also participate in URL parsing to parse just the bare URL, inject username password authentication or another type of authentication, go to the driver, get a connection, done. That's the idea of that. So what can you do today with that? So R2DBC is alpha quality. And this is already a major step forward, because last year in fall we announced that we are doing something on that end, and that at that time it was experimental. So we didn't had a real idea how to progress and how to continue from that on. And today we have a couple of drivers, which are H2, Microsoft SQL Server, and the Postgres driver. You can do things like batching. You have an extensive type conversion system that you can convert between the date types, numeric types, these kind of things. We support save points, transactions, isolation levels, basically these things to get started to spin up an application that is able to interact with SQL and your SQL database. And the funny thing though is R2DB started at back then at a Spring 1 conference. So typically the Spring team meets one time a year. So that's basically also the one time that everybody sees everybody within the Spring team, because we are distributed across the globe. And then somebody had an idea, yeah, you know, we need to do something. Let's do something. And that's basically how it started. And a colleague of mine just took a weekend off and started coding something. And that's how these things were born. And the idea is to not stop there, but rather progress across the milestone mark, progress across the release candidate mark, until we'll eventually get to a state where all this can be considered stable and be used also in production. And that being said, don't use it in production now. So RTDBC has started as a single thing. But over time, the ecosystem around RTDBC evolved, and we have the SPI itself, which is an artifact. We have the specification, a written specification, how things are supposed to work. We have various driver implementations that are driven by our own folks, and that were just started out of curiosity to see how these things are working. And over time, a couple of other projects started to join us. We have R2DBC Pool, which is the similar thing to what we have with data source proxy. Sorry, R2DBC proxy, which is the similar thing to data source proxy, which is an interception proxy, so you can hook into callbacks. The community started to work on actually 2 drivers, and literally 2 days before, we received the first driver implementation that is able to integrate with MySQL. And I think that's a strong sign that there is demand for these kind of things, and that the community is starting to adopting these things. We have 2 client implementations that are working already, and we are in contact with a lot of other people that are interested in that topic. But let's spend a minute on the RTDBC proxy itself. So the very first ticket that we received for RTDBC was, okay, this is cool, but how do I get metrics out of that? How do I get tracing out of that? How can I plug into that? Is it the same way ugly as we have it today with JDBC, or is there something better? And then the same person who started working on data source proxy started working also on RTDBC proxy, and this project became eventually so cool that we decided, okay, let's promote it to top-level RTDBC project. And this project basically allows you to register interceptors and hooks that get notified when you issue a SQL query, when you complete the SQL query, when something exceptional happens. That reports you not only the SQL itself, but how long something took, with which server you were talking. And that's a very strong foundation for application performance management tools like Datadog and these kind of things. You get a lot of metrics information out of that you can push into your Grafana or Prometheus, that you can put into Micrometer and ship these metrics somewhere else. You can get tracing information out of that to put it into your Zipkin or your open tracing integration. And that's a very strong primitive, which makes us really feel, yeah, now we are prepared with at least the observability part, and that we have to solve only the pooling part and the stability part, I guess. So what about the alternatives? Typically, when we start talking about async and databases, people come up with, yeah, you know, there's executor service, there's a thread pool. Why don't we take that route instead of inventing something which is much more complex and probably not really stable or known? And there are 2 answers for that, and every answer to that is don't do it. So here's the reason why. If you have a non-blocking system, then if you start looking on JDBC, you will see JDBC APIs are blocking because they are awaiting until some response comes back. And as soon as you drop in a blocking component into a reactive or non-blocking system, you basically lose immediately all your benefits. Done. So you can do one thing, put it on a thread pool to make it virtually non-blocking. So you spend an amount of threads to just offload that blocking work, and then from caller side, it looks like as if it was non-blocking again. Cool idea, basically. Thing with that is, with reactive programming, you also try to reduce the number of threads. So in an imperative Tomcat style, you have maybe 50, 100 threads, while your machine has 16 cores, something like that. So these are a lot of additional threads which need scheduling, which come with overhead, and all that context switching comes at a price. With reactive programming, you try to match the number of CPU cores and your thread, which means 16 cores in your machine, 16 threads, done. But if you spin up an additional pool of threads, you again get these negative effects of thread switching and additional management over threads. So while this isn't exactly the worst thing that can happen, another thing comes into play. So when we are talking about a lot of requests, only this number of available threads can be kept busy. Say we have 20 threads in our thread pool, but we have thousands of requests. We can do only 20 things in parallel. So what do we do with this 900 other things? Well, typically we put that work into a queue. And the queue can be bounded or unbounded. If it's unbounded, we will eventually run out of memory. If it's bounded, well, then we get back into blocking behavior. And so putting JDBC on a thread pool might be a good idea for testing, but besides of that, that's not a good idea at all. There's an obvious elephant in the room, although we do not see it here physically before us. The Oracle started with an initiative that is called ADBA, and ADBA stands for Asynchronous Database Access. And the goal for ADBA is to provide asynchronous database access, not reactive database access. So there are some differences, and especially in how we deal with a lot of data. When we talk about a lot of data, we tend to think in the imperative model of a list of rows or a list of T. And the very same is true for asynchronicity. So we no longer get a completable future of T, which is just one row, but we get a completable future of list of T. So potentially a lot of data. And with reactive programming, we strive for the idea of efficiency. So we want to process one row after another and not accumulate everything, wait even longer until the final bit has arrived, but we rather want to start processing data as soon as possible. So completable future can be a good intermediate solution, but that's not something that we strive for as the ideal solution. We started playing with RTDBC over ADBA, but soon we realized the only working implementation for ADBA is ADBA over the JDBC, and there they are putting, again, threads on a thread pool, or blocking calls on a thread pool, which is basically where we started. So that's not the perfect solution for us either. So what do we will see in the future? Well, currently the SPI is still evolving. We are learning. The most recent learning was about stored procedures, that stored procedures are still a thing and people are using it. So we are doing specification work for that. We are working on blob and clop API abstractions to deal with large objects. We are looking for driver implementers, driver vendors, to provide drivers for mainly MySQL to evolve over time as well on that end, but also some commercial databases like DB2. The ultimate goal for us is, however, to get in touch with the vendors and let them maintain these implementations themselves. We as a Spring team, we want to solve a particular problem, and we started to solve it, but we aren't really driver maintainers. We aren't the folks which have the deep knowledge of wire protocols and SQL database internals, but rather we know how to solve these kind of things on an application level. So we are talking with IBM, we are talking with the Derby folks and many other folks that are providing databases to get in a mode where we can give them just what we created, and we are collaboratively working on such a driver. We need connection pooling. That's something which is essential for production usage. It is just too expensive to always create a connection from scratch. So that's something which is already in work. We were involved in the microprofile community. We were talking with MyBetis and JDBI folks to add implementations for their clients. We were talking as well with Lucas Eder, who is the lead for Juke, to add execution support for RTDBC. So there are a lot of things that are ongoing, and that's a very good sign for us that we will face a viable community. However, the ultimate goal, or the initial goal even, of RTDBC was to influence ADBA. And the thing is, we weren't able to do so. However, we are not going to tolerate a bad ADBA specification. In that case, we are going to carry over with our work and follow just the thing that we think is the right thing to do. So, if you want to get involved into RTDBC, there are a lot of resources. Everything lives in the open source space. Everything is Apache version 2 licensed. We have a website that will take you through a couple of talks, in-depth talks about the technology, reactive database access, how these things are supposed to work. We have a Twitter handle at RTDBC. We have a GitHub organization, same RTDBC organization. We have an open mailing list. We have weekly calls where everybody is invited to join the discussion around the current progress, the current efforts, or even if you have to present something, or you want to ask for a specific functionality, everybody is invited. You will find all the details on the website, and if you just type in RTDBC into Google or Bing or Yahoo, these search machines will take you there. And that having said, this marks then the end of my presentation. If you have any questions, feel free to ask. Otherwise, I will be around for today and tomorrow. And thanks for your time. Enjoy DevWorks.